Okay, so good afternoon, everyone. Hello, can you hear me?
Good afternoon, sir.
Good afternoon too. All right, it's already 3:32, but we'll wait 3 more minutes for the others. All right, while waiting, to those who haven't submitted their video, their 1 minute video on this getting to know you better, so please do submit them as soon as possible. Okay. Well, the due date is September 13. You still have 2 weeks. The sooner the better. Okay. I need more information. What are things that you are expecting on this course? Okay. Or your expectation on the instructor. Okay. Things that I might need to improve. I need to change. Okay. So those are very, very important feedback. So no one's new. Like all of you here, I already know all of you. I'm already familiar with your names, but maybe the faces is not that much since we are in online distance learning. So I'm only seeing your names, okay, and then I only maybe perhaps know 50% or 60% of your face, okay, but not that much. So whatever you're using as your profile picture, then that's the only thing that I can remember. Okay, so 1 more minute. Ilan ba kayo dito? I think dami rin
Sir, di
yata.
pa updated yung canvas ni Alexa.
Yeah. Oo nga eh. May mga tatlo yata, dalawa sila na hindi pa daw updated yung canvas kahit nakabayad na. So, wala tayong magagawa doon since ang nagpa-process kasi nun is yung MIS. And uh, mga parang faculty to MIS lang yung nakakapag-usap. So, hintayin na lang natin. Okay. So, wala kasing contact yung student sa MIS eh. Anyway, so ito yung mga kaklase nyo. Well, ay, hindi nyo pala kita since hinide ko yung people. Well, anyway. So, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So, parang 24 kayo. Like 25 actually. So, ibawas nyo ako like 24. So, right now, there is 12. So, less me again would be 11. So, at least half of the class are here right now. All right. So anyway, it's already 3:35 and we can't afford to wait any longer since we're limited in time. And then we wanted to finish this one as soon as possible since I know that you guys have a lot of things to do. Okay. And anyway, so this chapter one is super simple. Most of them are, just the basics of electronics. All right, so since most of you already know how to use Canvas, okay, since you guys are already third years, second years, or third years, so I will not give you guys a short walkthrough on how to, what is this homepage all about. Okay, this is where you can see announcements, the syllabus, etc., etc. But anyway, so this is the topics that we are going to discuss. So of course, as usual, from week 1 to week 3 will be your midterms, and then from week 4 to week 6 will be your finals. Okay, and here's the overview for the week 1. Sorry, excuse me. So just click this one, then of course it will lead you to the topic learning outcomes and then the topics that we are going to discuss for the module 1. Okay, and then I've also prepared here a 3 YouTube link. So I would say that even though you, let's say you have zero knowledge when it comes to electronics, just by watching these 3 videos, it will enlighten you to, let's see, up to 80%, okay, or 90% of knowledge or ideas or basics of the things that you need to know when it comes to electronics. Okay, so make sure to watch them. And of course, also, okay, you have to read this PDF right here. So this is a 45 slides, if I'm not mistaken, 46. Okay, so this will teach you the basics of electronics. Well, anyway, so before we go to the official discussion, so I also have prepared here some practice exercises. So these are external links where you can check, okay, your basic knowledge when it comes to electronics. So we have props and then quizzes, okay. And then I also prepared, okay, let me just remove this one, module feedback. And then I also prepared one case study, of course, for the module one. So the same as what we have or as the format of my modules in electrical circuits. So we also have case study right here. So just visit this one, and then of course it will give you some facts, okay, and then the question. Okay, so somebody already answered this discussion right here. Okay, so do you guys have a question so far before we proceed to the official discussion?
Answer.
None, sir.
Okay, great. So is my voice clear so far? Is it loud enough?
Yes, sir.
Okay, great. All right, so let's start now with the electro or intro to electro. Someone send a message. Okay. All right, so without further delay, what is like electronics? So when we say electronics, it's actually the study how to control the flow of electrons. Period. That's the very straightforward meaning when we say electronics. Okay. So of course, in electrical circuits, we've learned how to compute, calculate the values of resistors, the voltage, what is the voltage across this one, what is the current across this path, and so on and so forth. But in here, we don't do that one. Okay, we can still use the fundamentals of electrical circuits, but mostly, okay, we're trying to use certain devices wherein we can control, okay, the flow of current, okay, or the flow of electrons. Okay, so it deals with circuits made up of components that control the flow of electricity, like the vacuum tubes. Okay, so these are the vacuum tubes. So we have different kinds of vacuum tubes. Those can control the flow of electrons or flow of electricity. Okay, we also have transistors right here. We also have diodes. Okay, this one is photodiodes, but this is still a diode. Okay, and then we have ICs or integrated circuits, and then we have here optoelectronics, and then other sensors that has the capability to control electronics. Okay, so we also have passive electrical components and then interconnection technologies. Okay. So next one here is an electronic component is any physical entity in electronic system used to affect the electrons or their associated fields. Okay. So if there is a contact on the electrons and then we can control that one, that's already electronic component. Okay. Well, there, yeah, electronic components or electronic devices, we only call them such thing. Okay, it's either a component, one component, or electronic device, which is composes of many components. Okay, so those are the physical entities that we are saying when we say electronic components or electronic devices. Okay, and then components are generally intended to be connected together. Okay, so of course you have to connect them, like this one has its own function and then this one has its own function, and then combining them together will give you another function maybe. Okay, or it will allow you to control the electrons. Okay, so depending on what you are trying to build. So usually by saying soldered to a printed circuit board or the PCB to create an electronic circuit with a particular function, for example, an amplifier or a radio receiver or oscillator. So these are examples of, like, for example, combining components. You can build an amplifier. So let's say from uh, a very low voice or low signal, you can amplify that one. Okay, like for example, also in a radio receiver, just by combining components, you can come up with this kind of device. Okay, wherein you can perceive a signal or a radio signal. And then lastly is oscillator. Okay, and then components may be packaged singly. Okay, so it's also possible, like this one is only IC. Okay, that's already uh, one device, okay, or one component. But of course, that IC composes as 40 or 30 transistors, resistors, capacitors inside of it. But in PCB, okay, so I hope you guys have already an idea. Okay, what when we say PCB? So PCB is a board, like a motherboard. Okay, wherein you will see a lot of ICs in there. Okay, so in that, it's already complex groups of integrated circuits. So pwedeng isa lang, pwedeng marami. Okay, and then most of the common electronic components are capacitors, inductors, resistors, diodes, and transistors. Okay, and then components are often categorized as active, like for example transistors and then thyristors, and then for passive, this is like what you have learned in electrical circuits. Transistors, but diodes, this is new to you guys. Meron din tayo inductors and then capacitors, but not that much. But mostly, it's just the resistor, which is the passive components that you guys have learned last time. Okay. Well, anyway, those are the examples of electronic components. Okay. So here are the history of those electronic components right here. The big vacuum tubes. What else? Isa lang. Okay, so hindi ko yata nilaging iba. Well, anyway, since ito lang kasi yata yung, if I'm not mistaken, okay, so to make it clear, I already created or I already have a PDF or a PowerPoint presentation 2 years ago. And then, ito yun. Okay. So, I think ito lang yung inilagay ko, if I'm not mistaken. Ito lang nilagay ko kasi ito yung parang isa sa mga sinauna. Okay, which is the vacuum juice. Wherein I think we are still using it, but not that much anymore. Okay. But I guess meron pa dito yung, diba? Wait lang ah. Okay, so I think it's in a separate slides. But anyway, so yeah, let's talk about vacuum tubes first, or sometimes we call that one thermionic valves. So we're among the earliest electronic components, and we're almost solely responsible for the electronics revolution of the first half of the 20th century. Okay, so bago pa yung mga iba, mga bago nating mga components, mga varistors, diodes. Ito yung pinakaunang-una, like 1900s, 1950s, bago mag-2000s. Ito yung isa sa mga pinakaunang-unang electronic components that has the capability to control electronics or electricity. Okay? So it allowed for vastly more complicated system and gave us radio. So una-una pa lang, meron na tayong radio, and then we have television, we have phonographs, we have radar, long distance telephony, and then much more. And then played a leading role in the field of microwave and high power transmission, as well as television receivers until the middle of 1980s. Okay. And then since the time, solid state semiconductor devices have all but completely taken over. So vacuum tubes are still used in some specialist applications such as high power RF amplifiers and then cathode ray tubes, okay, and then specialist audio equipment, gear amplifiers, and then some microwave devices. Okay, so this is just a short history, but yeah, that's it for the vacuum tubes. And then the next one is the atom. So before we dive in how to control electricity, so let's talk about atom first. So I know that all of you already know what is an atom. So atom is the smallest matter in the entire world, entire universe. Okay. So atom is a Greek word which means indivisible. Okay. So hindi mo na siya mahati pa. And then the Greeks believe that matter can be broken down into very small, invisible particles called atoms. Like This one is quite ambiguous or quite ironic actually. Since sabi dito kasi, ano say indivisible, hindi mo na mahati. Like, yan na yan, one single particle na lang. But they said that it can still be broken down into a very small, invisible particles. Okay? Which is, later on, pupunta tayo dyan. But before that, so Greek philosophers such as Democritus and then John Dalton put forward the concept of the atom, which is this one. So it says here that the structure of an atom can be basically divided into two parts. We have the atomic nucleus and then the extra nucleus part. Okay, so to to make it exact, this one itself is an atom, and then supposedly ito yung smallest particle natin. But how come that we can like dissect it more and then categorize the parts of an atom since ito na nga dapat yung pinakamaliit. Okay. So any feedback regarding with that one, guys? Kung bakit ganon? Anyone can explain? Hello, hello?
Hello,
Anyone who
sir.
has an idea? So atom is the smallest particles on Earth, right? Like it's indivisible. But how come that we can still divide it into, let's say, they can even identify it. We have the proton right here, we have the neutron, we have the electron, and then this entire proton and neutron is one nucleus. Anyone was an idea regarding with this?
Wala, sir.
Okay, Mr. Eisel de la Cruz. Are you there?
Yes, sir. Dito ako. Pero sir, I don't I don't have any idea about that, sir.
What about you, Miss Jade Ventura?
Same, sir. I don't have any idea.
So hanggang ngayon, nagtataka pa rin ako since we all know that atom is the smallest particles on Earth, but yun nga lang siguro since syempre nakikita natin yung atom, like maybe we can see it using a microscope. Okay. But it says here that very small invisible particles. So parang hindi na natin nakikita mismo yon kahit ano pang gamit natin siguro ng technology. Okay, but it says here, yeah, invisible. So that's maybe how define the smallest particles. Kapag hinati mo pa, invisible na yun. Okay, like those invisible things are proton, neutron, and then electron. So this nucleus right here composes of proton and neutron. Okay, and then for you to be able to see that this is one atom. Okay, so it has electrons evolving around it. Okay, so those are the extra nucleus part, which is the electron right here. All right. Well, anyway, so these are the things that you guys need to take note. So when we say conductors, it only has or it's ranging from 1 to 3 electrons. Okay. So napakasimple. If 1 to 3 electrons, then it's conducting. Okay, the more electricity that will flow on that conductor or element. Okay, and then we say semiconductors, it has exactly 4 electrons. Okay, so wala nang range. Basta kapag eksaktong 4, it's already a semiconductor. Okay, and then insulators electrons are ranging from 5 to 6 electrons. Okay, so we could see that the lesser the electrons, the more electricity that can flow on that element. Okay, the higher the electrons, the more that it's resisting or stopping the flow of current or electricity. Okay, so let's talk about again AC and DC. So last sem in your electrical circuits, we've only talked about DC, but para hindi kayo mahirapan, i-introduce ko na rin yung AC doon in your laboratory. Though wala masyadong explanation, but yeah, I hope you guys have realized how AC works. So we have a peak-to-peak voltage, like the positive and negative. So laging ganun. Okay, it's a sine wave when say AC, but when say DC, it's on the positive side only. Okay, So diretso lang siya. So alternating current is the electricity flows in alternating direction. This kind of current is measured in hertz. But for direct current, electricity flows in one direction. So a circuit is a complete and closed path through which electric current can flow. In other words, a closed circuit would allow the flow of electricity between power and ground. An open circuit would break the flow of electricity between power and ground. So in here, it's just discussing about the open circuit and then a closed circuit. So closed circuit, it has a flow of current, and then open circuit, it doesn't have a flow of current, just like this one. Okay, and then when say AC, so I mentioned this one a lot last sem, okay, in electrical circuits. So when say AC, that is the one that we have in our outlets. Okay, and then DC could be coming from a battery or the charger of our laptop. What else? Or yung mga iba pang devices, I cannot think of any other device that converts AC to DC. So kung yung nakikita nyo sa mataba, yung mataba na parang ano nyo sa charger ng laptop, that's the converter. Okay? Kasi sinasaksak nyo siya from AC and then i-convert niya into DC. Okay? So kailangan ng laptop natin ng stable current. Okay? Hindi pwedeng positive to negative. Masisira yung laptop. Anyway, here are the basic components. So, when ito na lang, sa resistor, hindi ko na ipapaliwanag to. Alam na alam niyo to. I'll just give one sentence each one of the components, each one of these components. So, resistor resists the flow of current. Okay, yun na yun, or reduces the flow of electrical current. Okay, and then you can read more if you want, but that's already it. Okay, and then capacitors. So you could say that capacitor is like a battery. Okay, pero saka lang siya gagana as a battery kapag connected siya mismo sa circuit. Okay, so it doesn't really store an energy or an electricity. Okay, but this one, so capacitor's component that stores electricity and then discharges it into the circuit when there is a drop in electricity. So, napakagandang sa lahat ng devices natin meron tayong capacitor. Kasi, I will explain this one. So, if we don't have a capacitor, let's say this is a television, okay? So, kapag walang capacitor, kapag biglang nag-brown out, parang yung current mo sana, di ba, dapat diretso lang. Kapag nag-brown out, bababa yan or magiging zero. So, positive, negative. So, bababa siya bigla. Pero kapag may capacitor ka, okay, if you have capacitor, so kapag kunyari, baliktad kasi yung graph ko eh. Ito na lang. So, nag-umpisa tayo sa positive and then if biglang nag-brown out, so ganito yung pagbaba niya. Okay, so it's in 90 degrees slowly. So with that, hindi mabibigla yung mga components natin. Bagkos, naging Tagalog na. But, you know, it will keep your components safe. Okay, so, and the same, vice versa. If we have a sudden fluctuation, okay, of electricity, so yung pagtaas niya, ganito rin. Okay, it will charge the capacitor first, and then once it's fully charged, then it will become stable. Okay, so different values of capacitors has different capacity to store electricity in them. Okay, so I hope you guys have understand how a capacitor works. Well, just in case you need more information when it comes to capacitors, so you can search this one on YouTube. So this will give you maybe 5-minute video or 3-minute video. So that's, I think it's already enough for you to be able to understand how a capacitor works. Okay, and then we have two types of capacitor right here. We have the polarized, this one, yeah, this one is a polarized, and then this one is the non-polarized capacitor. So ceramic disc is a non-polarized. So when we say non-polarized, it doesn't have a polarity. So pwede nyo siyang pagbaliktarin. Okay, it will work perfectly as a capacitor. But the electrolytic capacitor that is, you know, like small cylindrical tubes like this one, Okay, this one is polarized. So I think ganito na lang, obvious naman sa lahat ng components, if we have a shorter leg, means that's a polarized component. So you have to follow the proper proper kalimutan ko yung term, pero yung proper na paglagay. Okay. So the shorter one is for negative or ground, and then the longer one is for positive. Okay. So both of them work the same. Okay. It's just that if you want a polarized capacitor, then use this one, and then if you want a non-polarized capacitor, then you can use this one. All right. And ceramic disc capacitors are ito na yun. So I already explained this one. Okay. So I will skip this one now. Okay. So this is the non-polarized, and then this one is the polarized capacitor. So any questions so far, guys? Okay, so there is a question right here. So, sir, how is UPS connected to our lesson? UPS, where did that came from? Yung like emergency power, right? So, saan mo nabasa yun? So, did I say UPS a while ago? Like you're asking how is it connected to our lesson? You're only asking what is the idea about UPS maybe? Because I didn't mention about UPS in here. But anyway, so yeah, UPS is an interruptible power supply. So ginagamit siya mostly sa mga PC na kunyari, meron ngang sudden power interruption. And then para ma-save mo yung ginagawa mo, so yun, kapag nag-brown out, it will give your PC a power. Like maybe for 30 minutes. So depende kung gaano kamahal or kaganda yung UPS. Okay, so ginagamit ko sa console ko Sir Lai kasi nagbarban dito. Hmm. Uh, Hindi siya parang ganun. Okay, so UPS really stores an energy. So para talaga siyang battery. Okay, hindi siya kaparehas ng capacitor kasi na-mention ko kanina yung parang sudden drop out of current, right? So capacitor is just a safety components para maiwasan yung biglaan. Okay, like for example, kasi 'di ba kapag nawalan yung kuryente, supposedly dapat 220 volts lang to. But for some reason, kapag kakarating lang ng kuryente, okay, hindi lang 220 volts to, minsan umabot pa ng 500, umabot pa ng 600, kaya nasisira yung mga components natin. Kaya nga 'di ba, pag sinasabi ng mga magulang natin, kapag may brownout, patayin mo muna lahat ng mga gamit, tanggalin mo muna lahat sa saksakan kasi masisira yung mga gamit. Pero safe na lahat. So meron lahat ng mga devices natin yun or mga appliances is safe na sa mga ganyang pangyari. Okay? Kasi syempre na-anticipate nila yun. Alright? Okay, so capacitor, yung pinakasagot dyan. So, one more thing, ito rin siguro yung, napapansin nyo rin siguro to sa TV. Diba kapag nag-brown out, merong LED indicator doon na yung iba red siguro, yung iba green. Pero pagka brown out, umiilaw pa rin yon. Okay? So, that is that TV has a capacitor. So, unti-unti siyang, or konti-unti niyang i-deplete mismo yung na-store niya na energy. And then, ayun, parang safe siyang namatay. Okay, parang namatay lang din siya ng normal lang. Unlike kapag walang capacitor, so bigla ang mamamatay na lang lahat, which can cause a damage to your components. Okay. So yung parang LED indicator dito. So depende sa TV nyo. Okay. Pero yun yun. Okay. So any other questions so far? Question, anyone? So time check, we now only have 6 minutes left. So nasa slide 13 pa lang tayo. Well, anyway, mabilis lang to. Question?
None, sir.
Okay. So just in case that you have a question, so just speak right away. Okay, again, you don't need to raise your hand anymore. You can interrupt me anytime. Okay. Okay, next one is diodes. And then in here, ito na yung pinakalagi natin gagamitin. Okay, so I would like you guys to search more about diodes. So ito yung magiging parang assignment nyo. Okay, self-study assignment. But of course, it's not graded. But just do that one. Okay, you're helping yourself since ito kasi yung para magiging component na gagamitin natin throughout this course. So diodes. So they are polarized. So you have to follow proper representation of follow the correct polarity of that one. So they only allow electrical current to pass through them in one direction. Okay, so meaning if you flip that one, okay, like positive to negative and then negative to positive, wala na mag-flow na current. Okay, so it will prevent the electricity from flowing in the wrong direction. So ang ito yung isa sa mga pinakamahalagang components, okay, sa mga appliances natin. Kasi AC tayo, di ba? So mostly, kapag AC, mayroong positive and then mayroong negative. But in diodes, okay, it will only accept the positive, let's say, electricity or current on that path. Okay, o hindi naman sa entire device or entire appliance, but in that certain IC only or certain electronic components. Okay, so it will only accept positive, okay, and or pwede mo rin baliktarin basta negative to negative and then positive to positive. So sometimes it can also accept only negative and then it will neglect the positive. Okay, so yeah, it only allows one flow of direction. Okay, and then it prevents the other. So another thing to keep in mind is that it requires energy to pass through a diode, and then this results in a drop of voltage. So this typically lasts at about 0.7 volts. So in here, sa silicon lang naman to eh. Sa silicon, it's 0.7. If I'm not mistaken, in germanium, it's 0.5, okay, or 0.4 yata. So we'll discuss that one on the next modules. So next meeting pa yan. But yeah, diodes eat up a certain voltage before you can pass through a certain voltage. So if you have a voltage source of 5 volts, so kinakain niya na kaagad yung 0.7. Okay, and then it will only permit the remaining voltage. So ang natira na lang is 4.3 volts. So if you're needing exactly 5 volts, dapat 5.7 volts yung source mo. Okay, since it will eat the 0.7 volts and then it will allow the remaining 5 volts. Okay, so the ring found on one end of the diode indicates the side of the diode which connects to the ground, and this is the cathode. Okay, so ground is cathode or negative side of the diode. So it then follows that the other side connects to power, which is the anode. So anode is the positive, okay, or ano pa ba? Yeah, positive lang. Basta kapag cathode, it's negative, or ground, and then if it's anode, it's connected to the positive or to the power. Right? So next one is transistors. So in here we have two types of transistors. We have NPN and then PNP. So NPN, dito tayo sa NPN muna. Okay. So we have this kind of symbol, meaning this one is flowing, okay, from collector to emitter. So that's the flow of current of this transistor right here. And then we have the PNP, okay. We in here it's the other way around, so it's flowing from the emitter going to the collector. Okay. So this one also has the capability to control the flow of current, okay, or could say we can also add more transistors to come up with a switch. Okay, so with that we can now control the flow of current, or the flow of electricity. Okay, so yeah, NPN and then PNP. And then we have here ICs. So IC is just composed of many components inside of it. So we call them miniaturized. Okay, miniaturized components. So napakalit na ito. So imagine ganito talaga yung size niya. And if you are going to take a look on this one, it's like it can only fit uh, 6 components. Let's say capacitor, resistor, and any other components that you can fit in here. But believe me or not, this one can, it might contains 30 to 50, okay, or even 40 or even 60 components inside of it. Okay, so what are those components? So of course they could be transistors, resistors, diodes, capacitors, and so on and so forth. Okay, so mas pinaliit pa sila. Okay, and then each pin, okay, has its own meaning, or call this one function. So mostly this number one right here is the power. Okay, where is that one? Well, anyway, so mostly ganun, power and then ground and then 5 volts, and then mostly on the right side are the functionalities, like what it can do on this number 7, number 6, number 5. Okay, so yeah, depending on the IC itself. Okay, but in here, as you guys can see, we have a small notch. Okay, the round notch on one edge of the IC chip indicates the top. Okay, so para hindi kayo malito, kasi hindi natin alam kung nasan ba yung pin 1, pin 2, pin 3, pin 4, and so on and so forth. Okay, so just find the notch. Okay, nasa gitna yan, or minsan nasa left side, or yeah, gitna or left side. That is the top side of that IC. Okay, so you'll